Hello everyone. Today we're going to do a packet tracer of CCNA 3 version 7, 5.2.7. Packet tracer. Configure and modify standard IPv4 ACLs. This is addressing table. Objectives. Part 1. Verify connectivity. Part 2. Configure and verify standard numbered and named ACLs. Part 3, modify a standard ACL. Background scenario. Network security and traffic flow control are important issues when designing and managing IP networks. The ability to configure proper rules to filter packets based on established security policies is a valuable skill. In this lab, you will set up filtering rules for 2 business locations that are represented by R1 and R3. R1 and R3. R1 represents the Office 1, this location. Office 2, R3 represents Office 2, this location. All right, so management has established some access policies between the LANs located at R1 and R3. Because there are some LANs on R1, the LANs on R3, okay, which you must implement. The edge router sitting between R1 and R3 has been provided by the ISP, will not have any ACLs placed on it. The edge router, you don't have to do anything on this router. You would not be allowed any administrative access to the edge router because you can only control and manage your own equipment. Instructions, Part 1, verify connectivity. In Part 1, you verify connectivity between devices. Note, it is very important to test whether connectivity is working before you configure and apply access lists. You want to be sure that your network is properly functioning before you start to filter traffic. Okay, we start to verify the connectivity. First, from PCA, pin PCC, and PCD. Pin from PCA to PCC and PCD. Okay. Pin PCA to PCC. Here's the PCC. Let's quickly take a look at this IP address. Because here, the first 2 decimal numbers are the same, 192, 168. The only difference is the last 2 numbers. The PCA is 10.3, PCB is 20.3, PCC is 30.3, PCD is 40.3. Right, so let's ping PCC. From PCA to PCC is successful. Okay, so next ping PCD is 40. It's successful. Good. And now next is R1. From R1 pin PCC and PCD. R1 enable pin PCC. Yep, successful rate 100%. Good. And then we pin PCD 40. Yep, successful rate 100% is successful. Good. So next, from PCC, pin PCA and PCB. So from PCC, pin PCA and PCB. Okay, let's go. Pin PCA, PCA. Yeah, from PCC to PCA, successful. Then PCB is 20. Okay, here. And PCB. Yep, successful. Use a 10, 20, 30, 40. Okay, good. So now we need to test from R3, from R3 to PCA and PCB. Enable PCA. Yeah, successful rate 100%. And PCB is 20. Successful. Good. How about the next one? Next one is can all the PCs ping server at 209.165.255. This is a server. Okay, from all PCs, PC A, B, C, D, to ping the server. Let's go. Yep, successful. Good. Okay, here's PCA. Then we ping from PCB. PCB to server successful. And the PCC to server successful. Good. PCD. Successful. Okay, so now all the devices are full connectivity. That is, yeah, so we test the connectivity. The next step, we need to step part 2, configure and verify standard numbered and named ACLs. Step 1, configure a numbered standard ACL. Standard ACLs filter traffic based on the source IP address only. Source IP address only. Okay. A typical best practice for standard ACLs is to configure and apply the ACL as close to the destination as possible. Configure and apply ACL as close to the destination as possible. Okay. For the first access list in this activity, create a standard numbered ACL that allows traffic from all hosts on this 10.0. So it's a PCA network. This is a network where the PCA is on, is from here. So allows all the hosts on this network, PCA network, and all hosts on the PCB network, A and B, allowed all the hosts from A, PCA network and PCB network to access all the hosts on PCC network. Okay, so allow PCA and PCB to access PCC network. Good. So the security policy also states that an explicit deny any access control entry ACE, also referred to as an ACL statement, should be present at the end of all ACLs. Okay, what wildcard mask would you use to allow all hosts on the 192.168.10.0/24 network to access the PCC network? Okay, the question is, what is the wildcard mask of the /24 network? That's supposed to be 0.0.0.22.255. It's the same as this one. This is the wildcard mask we need to use. 0.0.0.255. Okay, the following Cisco's recommended best practice on which router would place this ACLs. So this ACL is allow PCA and PCB, these two networks, to access PCC, this network. So the source is PCA and PCB. The destination is PCC. So we need to configure and applied this ACL on R3, which is close to the destination, PCC. PCC's destination. So we need to configure and apply the ACL on R3. Okay, let's go. Configure terminal, access list 1, remark, or allow 1, length, access. This is when remark allow R1, R1 length, access. Okay, good. Okay, access list 1. Permit 192.168.10.0.255. Okay. Okay, here it's 20. Okay, let's take a look. Permit this network 10.0, and this is a wildcard mask. Okay, this is a PCA network, and the second line is PCB network. Okay. All right, so deny any. Deny any means deny all the other traffic from other devices. So now it's apply ACL to the appropriate interface in the proper direction. Oh, we have to do this. Okay, on which interface? We don't have answer this question yet. On which interface would you place this ACL? In what direction would you apply it? So we need to configure and apply on R3. And which interface? Supposed to be this interface, which connected to the PCA network, the network where the PCC is on this interface. Let's see, yeah, this interface G000. This interface, in what direction would you apply it? Direction is out. It's exit interface. Outgoing from R3 and enter this network where the PCC is on. Okay, so now we apply this ACL to the interface G000. Interface G000. IP access group 1 out. It is outgoing. Okay, so we finished the B. Okay, see verified numbered ACL, the use of various shell commands can help you to verify both the syntax and placement of your ACL as in your router. Okay, to see access list 1 in its entirety with all ACEs, which command would you use? Command we need to use is the show access list 1. What command would you use to see where the access list was applied and in what direction? We can use the show IP interface or the show run. Okay, let's start show command R3 show access list 1. Okay, show access list 1. Here's permit PCA, permit PCB network. Deny any, deny all other traffic. Good. So here is the ACE, and let's go to take a look at the placement. Show IP interface G000. Okay, here is here the outgoing access list is 1. So this interface G000 is outgoing out. And here it doesn't say, but we can try another show run. Okay, show run, we still can see it. Yeah, here is the access list. We configured access. Now we go to the interface G00. Okay, here you see IP access group 1 out. Good. So all these commands, show command we can use. All right, so I'll test the ACL to see if it allows traffic from PCA network to access the PCC. Okay, from PCA ping PCC. PCA ping PCC. This is PCC. Okay. Yep, successful. So PC from a PC successful. Yes. Okay, test ACL traffic from PCB network access to PCC. So from PCB ping PCC. Let's try. Supposed to be successful. Okay, ping PCC from PCB to PCC successful. Good. PCB PCC successful. Should ping from PCD to PCC be successful? I don't think so. PCD to PCC, I don't think it'll be successful because the ACL we configured on R3 only permit PCA and PCB, these two network to access PCC network. So let's try PCD ping PCC. Yeah, so destination host unreachable. So this traffic from PCD is denied by the ACL on R3. But also we can use the simulation mode to verify again. Okay, so here, ping from PCD to switch 4 to R3. Okay, denied, and R3 return it back to S4, then return back to PCD. Okay, so denied. And from the R1 prompt to ping PCC IP address again. So let's try from R1 to ping PCC to see it will be successful or not. I don't think so. Let's try. No, successful rate is 0%. It's unsuccessful. Okay, it's unsuccessful. Where is the pin successful? No. And why? That's because the ACL only permit the networks where PCA and PCB belong to access PCC. All other traffic from all other devices should be denied. So R1 would be denied too. Okay, issue the show access list. One comment again, note that the comment output displays information for the number of times each ACE was matched by traffic that reached the interface. Gigabit Ethernet 000. All right, so let's try again. Show access list 1. Okay, here's the 4 matches and 4 matches. Okay, here's the 13 matches. This is because we use simulation to test again. So okay, match. Step 2, configure named standard ACL. Create a named standard ACL that conforms to the following policy. Allow traffic from all hosts on the 192.168.40.0/24 network. It's a PCD network. 2, access to all hosts on the PCA network. Okay, PCD network to PCA network. Also only allow host PCC access to the PCA network. The name of this access list should be called branch office policy. Okay, so this ACL is named ACL. The name is called branch office policy. It will allow all the PCD network, all the hosts on this network, PCD network, and only host PCC to access PCA. So PCA, this time, PCA is a destination. PCC host and PCD network are the source. So following Cisco's recommended best practice on which router would you place this, we should place this ACL on R1. Because PCA is a destination, we need to place the ACL on the router that is close to the destination PCA. The PCC and PCD are source. Okay, so on which interface? R1 supposed to be on the interface G000. This interface is connected to the network where the PCA is on. Direction is out. Outgoing from R1 and enter PCA network. Okay, here's the direction is out, R1. Okay, create a standard named ACL branch office policy on R1. Okay, let's go R1. Terminal. IP access list. Branch office. IP access list standard. Branch office policy. Okay, I just checked the spelling. Okay, permit host. That's a host only. 192.168.30.3. This is a PCC's IP address. And permit network of permit. This time is permit the network where the PCD is on. Okay, 192.168.40.0.0.0.255. This is the followed by the wildcard mask. And okay, here, look at the first ACE in the access list. What is another way to write this? First ACE is permit host 192.168.30.3. This is PCC's IP address. The host means a specific PC. So another way, okay, I can show you here. Another way supposed to be I show you from here. Okay, it's here. This one is a permit. Another way to write, same meaning, 192.168.30.3. This is the IP address of PCC. So how to match this PCC is 0000. So this 0000, that is means need to match this IP address. Okay, this is another way of writing this ACE. All right. Apply the ACL to the appropriate interface in the proper direction. T interface G000. All right, IP access group. The branch. Okay, I just copy paste. Branch office policy. And out. Okay, here. So we applied this ACL on the interface G000. R1 G000, this interface. And verify the named ACL. Okay. So we show IP on R1 is to show IP interface command to verify that the ACL is configured on the interface. Show IP interface G000. Yep, here. So we can see on this interface, the outgoing access list is branch office policy is here. So it is applied. So test ACL from the command from the PCC ping PCA. PCC ping PCA. That's supposed to be successful. Oh no. PCA. Okay. PCA is 10. Yeah, successful. PCC to PCA, successful. Were the pin successful? Yes. Test ACL to ensure that only the PCC host is allowed access to PCA network. You must do an extended pin and use the G000 address on R3 as your source pin PCC. Okay, so on R3, use this interface G000 address as a source to ping PCA. Okay, let's use the extended ping. Okay, ping, enter, target source. Target IP address is PC. Is PCA's IP? Yes. Okay. Extended command. Yes. Okay, source is this one. Source is the IP address of interface G000. Okay, successful rate is 0. The UUUU is unsuccessful. So were the pin successful? No. So R3 pin PCA is unsuccessful. Yeah, it's the same reason because the ACL on R1 only permits PCC and PCD to access PCA. So R3 will be denied. Part 3, modify a standard ACL. It is common in business for security policies to change. For this reason, ACLs may need to be modified. In Part 3, you will change one of the ACLs you configured previously to match a new management policy that is being put in place. Attempt to ping the server at 209.165.254 from PCA. So from PCA to ping server. Server is here. From PCA to server. Notice that the ping is not successful. The ACL on R1 is blocking internet traffic from returning to PCA. This is because the source address in the packets that are returned is not in the range of permitted addresses. Management has decided that traffic that is returning from the server network should be allowed full access to the PCA network. Management also wants ACLs on all routers to follow consistent rules. A denying ACE should be placed. At the end of all ACLs, you must modify the branch office policy ACL. Okay, you will add 2 additional lines to this ACL. There are 2 ways you could do this. Option 1, issue a no IP access list standard branch office policy command in global configuration mode. This would remove the ACL from the router. Depending upon the router iOS, one of the following scenarios would occur. All filtering of packets would be canceled, and all packets would be allowed through the router, or because you did not remove the IP access group command from the G01 interface. No, it's G000. G01 is here. It's on the switch. No, supposed to be G000. So here's ignore it. It's not G01. And the filtering is still in place regardless. When the ACL is gone, you could retype the whole ACL or cut and paste it in from a text editor. Option 2, you can modify ACLs in place by adding or deleting specific lines within the ACL itself. This can come in handy, especially with ACLs that are long. The retyping of the whole ACL or cutting and pasting can easily lead to errors. Modifying specific lines within the ACL is easily accomplished. For this activity, we use option 2. We use this option 2. Okay. So step 1, modify a named access list, standard access list from R1. Okay, let's go to show access lists. All right. So this is the output standard IP address, IP access list branch office. Here there are 2 entries, 1020. The 1020 is the sequence number. So each one is ACE. So there are 2 ACE. So add 2 additional lines at the end of ACL from global configuration mode. Modify the ACL branch office policy. Okay, let's go to do the modification. Configure T IP access list standard. Okay, let me copy paste. I don't want to make mistake with the typing. Right. Okay, these 2 additional lines add. So because we have 2 lines already, one is 10, one is 20. So we start from the third one. It's we need to add 30. This sequence 30 and 40. So this is 30. 40. Okay, so 30 is permit is this network. This network is where the server is on. This network. It permit this network. Okay, so 40 is deny any. So deny any other traffic from other devices. The end. So let's verify. On R1, show access list. R1 show access list. Show access list. Okay, now before it's only 10 and 20. So now we add 30 and 40. So the output of show command list here, 10, 20, 30, 40. This is permit the host PCC. This permit the network of PCD. This is network of server, deny any. Okay, good. And do you have to apply the branch office policy to the still G00 interface on R1? No, because when we do the modification on ACL, we just add 2 additional lines into the ACL, but we don't remove the application. We still have application on that interface, so we can check it. We can double check. Show IP interface G000. No. Show interface G00. Sorry. Yeah. So outgoing access list It's still here. Yeah, the application is still here. So we don't need to redo this. We don't need to. Okay, test the ACL to see if it allows traffic from server network to return to the PCA network. From PCA ping, PCA ping the server. Let's do it. PCA ping. Ping request could not find host. Please verify. No. Yeah, successful. So from server to PCA is successful. From PCA to ping. Successful. There's something wrong here. Okay. 1209, 160, 200. Probably it's copy paste is not right. Okay, so it's successful now. All right, so it's successful. Okay, as you see, standard ACLs are very powerful and work quite well. Why would you ever have the need for using extended ACL? The question. Okay, even though standard ACL is powerful, but it's only filter on source address. But extended ACLs can filter on source address and also can filter on destination address, the filter on protocol like IP, TCP, UDP, and ICMP, and even the port number. So extended ACL can provide a greater range of criteria than do standard ACLs. The second question, more typing is typically required when using a named ACL as opposed to a numbered ACL. Why would you choose named ACLs over numbered? That's because the named ACL is easier to understand the function of ACLs. That is the answer. Okay, the completion status is 100. That means, yeah, we're done. We're successful. So we're done for this package configure and modify standard IPv4 ACLs. Thank you for watching my video. If you like my video and think it's helpful for you, please thumbs up and share with your friends and subscribe my channel. See you next time.